Okay, so we have one other company that forms part of cohort 4. Unfortunately, they had some last-minute things that came up and they weren't unable to join us today, sadly. They were, however, good enough to make a video that we can see their work despite them not being here. So I will click next and hopefully it will start to play.
Hello, my name is Eleanor, CEO at TELXAI, and I will be providing a presentation on our DSbD Technology Access Program Cohort 4 outcomes. At TELXAI, our goal is to deliver data integrity at every level, from the internal hardware through to the secure transmission of real-time video data. As such, TELXAI's goal for the DSbD Technology Access Program was to demonstrate video streaming and video analytics operating on the Morello board utilizing the Cherry protection model. So TELXAI's first goal was to compile and run its algorithms on the Morello board, followed by the cataloging the system performance with CheriBSD. Prior to the start of the project, TELXAI had very limited experience of working within the Morello CheriBSD, so the onboarding and documentation was extremely useful for setting the system up. The method we took was to work within the emulator. This was initially done to allow us to get a head start, but we continued using this approach throughout the project. One advantage this presented was a repository within CheriBSD that had attempted to port OpenCV to CheriBSD previously and allowed us to hit the ground running. The code and dependencies were then transferred to the Morello board. We had no issue using this methodology. Our aim for the project was to port our AI-based camera solution to the Morello board and provide protection against out-of-bound memory read-write attacks. We have achieved a simulation of the camera system running on the Morello board. There are no appropriate ports for our camera sensor on the Morello board, so we used an IP camera as a data feed instead. The video was then processed using the application running with CheriBSD on the Morello. The detection results were annotated onto the video and the results data sent to a standard I/O. And netcapped was used to transmit the video output in the form of a motion JPEG video stream to view the results we connected. OpenCV to Cherry C++, we ported over 1 million lines of code and we compiled OpenCV including its dependencies. However, we were unable to get FFmpeg to compile. One of the challenges around the CNN model was getting Google's protbuf library to compile and run, and we achieved this, and the rest of the process was relatively straightforward. The project was significant, but only a small percentage of the application needed modifying to compile on CheriBSD. Just for clarity, this was all run in pure capability mode with no hybrid components. TELXAI challenges faced include adapting the codebase, adjusting for additional memory requirements, and adapting for missing tools, such as libfuzzer. The limits enforced due to missing tools, such as libfuzzer, meant that the fuzz-based testing was limited. We developed a code which randomized the images and induced noise within the image data and also fuzzed the files. None of the fuzzing approaches produced any unexpected behavior. The limitations due to not having a Python or a Node.js meant that we could not port our dynamic web interface, and all interaction with the system was constrained to the terminal application. We were unable to compile FFmpeg, although this was not critical to the application, so little resources or effort was applied to the task. Due to the comprehensive documentation provided, TELXAI was able to adapt the codebase and pointer alignment. We found the initial tutorial combined with the documentation very useful, and we were able to overcome the compiler errors. Whilst utilizing Cherry and the Morello board, a performance trade-off was observed. However, there could be multiple reasons for this and may not be due to the Cherry architecture. One notable trade-off was related to the computational speed, resulting in slower inference through the neural network compared to the usual target hardware. The performance difference was approximately twofold, indicating a significant impact on processing speed. It is important to note that certain languages and frameworks were not fully supported on the Cherry Morello platform, which further affected performance with regards to the system feature set, i.e., we could not implement a complete solution specifically regarding our web interface. Here is a video of the system running. We perform basic tests to assess the protection provided by Cherry Morello against unauthorized memory access. These tests involved attempting to write to and read from protected memory locations, simulating out-of-bound reads and write scenarios. As expected, the system responded appropriately by preventing these unauthorized accesses. To uncover any unexpected behaviors or vulnerabilities, we employed fuzzing techniques. Since fuzzing was not available directly on the Morello board, we adopted an offline approach. We fuzzed the data on a separate workstation and then fed it into the application running on Morello. In our fuzzing test, we applied two methods. First, we fuzzed the files themselves, resulting in the generation of corrupt file types. However, OpenCV, being a robust library, correctly rejected these corrupt files as expected, demonstrating its resilience against potentially harmful input. Secondly, we fuzzed the image data within the file using three different approaches. The first approach involved creating a grid within the image and randomizing the order of pixels within each grid selection, along with adding random noise. The second approach entailed adding random noise at varying scales, while the third approach induced salt and pepper noise to the data. We utilised a raw data set obtained from our internal training system. In conclusion, Cherry met expectations in terms of porting and performance. If Morello was commercially available, we would continue to integrate it into our next generation camera, and TELXAI is keen to continue commercial discussions. Thank you.